Hello. In this video, I would be showing you how to print the bits in a floating data type variable. All right. Uh, 1 second. Yeah. So this is a float, and we have some data here, 3.64. And I'm going to show you how to convert that or show you how to print the bits representation in a C language. So the before we go, I want to just show you that um, you would be learning, or you probably know how to convert a float data type, and I'm using taking the address of that data and converting that in using a unsigned int pointer. All right, so its data was pointing here, so I'm also pointing. This is a float, but I'm now using a unsigned integer pointer. Okay, I'm going to use that to navigate. So they both are pointing to the first bit, right? And so how do I get to it, right? For a positive values, the bit position will be 0 at the 31st position, right? In a float, it's a 4 byte, right? 4 bytes. So that's why we have 0 to 31 bit positions. So how do I get that 1? So here, pretend I have a 1. I have 1 here, and I'm going to push this 1 all the way to the left up um, uh, to 31 bit positions. So the 1 will be here. When I push 1 all the way, okay, to the left by 31 positions, the remaining positions will always be 0, isn't it? Always be 0. Anyway, so this is what now I pushed this 1 by 31 bit positions to the left, and I'm going to take, this is my pointer pointing to this guy, we saw that. And if I do a bit and between these two, then I would know what the 31st position is. Is it a 0 or a 1? Isn't it? Right? So my algorithm is, if I could take the next PowerPoint paint. So if I say condition is, if pointer and with 1 shift by 31, if it is positive, I'll print 1. Print 1 means what? Then we have a signed bit is 1, that means it is a negative number. If it is 0, that means we have a positive number, right? So that is what I will do. That's what is basically. So this is for bit position 31. Now how about bit position? You pause the video and see how will you do it for bit position 30. What would you do? What would you change in this code? Right? Now pause the video for a couple of seconds, see if you can answer the question. Look at this code. For bit position 31, we use 31 here. And you want to get to know the bit position here. What is it? Is it 0 or 1? We don't know at the bit position 30. How do I get that value? So same code, isn't it? Instead of 31, we would use 30, isn't it? The same code, instead of 31, we would say 30. Similarly, for bit position 29, what would you do? How would you change the code? It's 29, isn't it? So how can I print all the values all the way up to bit position 0? I'll just change this 0, isn't it? So now in computer science, you know, you have a repetitive code, and now can I write a more optimal code? I would use a for loop, isn't it? Here, a for loop for starting with I equal to 31 greater than or equal to 0, I minus minus, the same code I have, the same code. I just changed this I, right? So here I have code for you. So here I have minus 3.64, and 1 second, I'll just take it here. We don't need such a big window. I just showed a simple window there. So the same code I have, right? The same code. There is no rocket science here, right? Oops, sorry. See that same code, whatever we wrote. So I'm going to take minus 3.64, right? Compile it. So this, whatever you see, is minus 3.64. So minus means we know the positive side, the bit position, the sign bit will be 1 for minus, right? So we have 1 minus there. That is 1, right? And the remaining 8 is exponent. You learned it in another course, maybe a discrete structure or something, right? And then we have 23 bits of Mantissa, right? So you can confirm with the third party code, third party uh, websites, and here I have minus 3.64. You let me just make sure that you can see the whole thing. I don't want to lose it. The website is of course h-schmid.net, and you can use that. And if you see this this value and what they have would match. You see, this should match. 1 1 exponent is 8, right? 8 is exponent, 8 bits. We have that 1 0 0 0 0 0 0 0, and then oops, and then we have the Mantissa 1101 1101. Anyway, you got the gist of the story. That matches, all right? So I can now show another number for a positive number. Let's take 8.693 maybe, right? This is a positive number. I'm going to compile it, and I'm going to run this guy. What was the value? 8.964, right? No, 8.693. 8.693. So if I go and plug it in, 8.693. So that should match what we have, is it not? 0, sign bit is 0. Then we have 1 0 0 0 0 1 0. So if you see here, it matches that. See, it always matches last. See, 4 zeros, 3 ones, 4 zeros, 3. So it matches. So our algorithm is right, right? So so I will upload this code, and you see how this is done. It's good to review and code it by yourself. If I were you, I would code myself, and for practice, and see if you're getting the same values. Okay, you got the gist of the story. Thank you.